Let's integrate this super fun integral, the integral of parentheses x to the fourth power over 1 plus x to the sixth power, and then raised to the second power. As you can see, there are a lot of things that you know you shouldn't do. For example, you should not use trig substitution, because here we have 1 plus x to the sixth power, right? If this was 1 plus x to the second power, maybe. And we should not do partial fraction neither, because if you want to factor this out, which I did, and I regret right away, and it's not just 1 plus x to the sixth power, it's to the second power, so yeah, so we should not do partial fraction for that either. And substitution, unfortunately, it doesn't work out nicely. I tried it, I look at this as x to the third power and then square. Unfortunately, on the top, it's, oh my god, this is x to the 4 and then to the second power. No good. So, yeah. And you can try to do this one as well. Just pause the video and try it. And this is how I did it. It took me 20 minutes today, and I was doing this for fun. Here, let's make some progress.
So what I decided to do is, I decided to just kind of work out the power, at least for the top. So this is the integral. On the top, I look at this as x to the 4 and then square. So I look at this as x to the 8 now. And then on the denominator, we have 1 plus x to the 6 and then square, right? I decided to not to multiply it out, because when I did, I regret. So let me just keep it as 1 plus x to the 6 and then square dx. And now we can look at this and then think about what can we do from here, okay? And this is my strategy, and you guys should have this kind of strategy in your mind as well. You should think about, wouldn't it be nice, okay? You should always ask yourself, wouldn't it be nice if you have a way to change this integral? What would you change so that you can make this question easier? Wouldn't it be nice if this is x to the fifth power instead, right? Because I know on the denominator, this is 1 plus x to the sixth power. If I do some u substitution, let u equals to the denominator, I get the derivative of this, which is 6x to the fifth power. And that x to the fifth power, if this was x to the fifth power as well, they'll cancel each other out. So that's very nice, right? However, I cannot just change the whole question. But I can break this into parts, isn't it? And you see, that's exactly integration by parts. If I can break this into one part that I know how to integrate, the other part will just differentiate. And let's just construct the answer by using integration by parts and hope for the best from there. So let's do that. Integration by parts and with my DI method, of course. So let's pick something to be differentiated and pick something to be integrated. And don't forget to have the plus minus on the side, okay? Integration part is the harder one, so you should always try that first, okay? Always pick something to be integrated first. And as I said, I want to integrate x to the fifth power over 1 plus x to the 6 and then square, okay? So hopefully this is going to give us good result. Well, what do we need though? This is not the original. This is x to the 8, right? So we need 3 more x multiplying together. So that's x to the third power. And remember, when you do the DI method, the product of each row, it's an integral. When you do this times that, that's the original integral, right? X to the third times x to the fifth. That's x to the 8 on top. So we're good, okay? And don't forget the plus minus sign on the side. And let me just do 2 rows for now. And as I said, hope for the best. Let's differentiate this first because that's the easy part. The derivative of x to the third power is 3x squared. This now we can integrate. And you see we are making progress. And to integrate this, I will show you real quick on the side with substitution.
So let's look at the integral x to the fifth power over 1 plus x to the 6 and then square, right? To integrate this, we have to let u equals to 1 plus x to the sixth power, and we know du will be 6x to the fifth power dx, and then dx will be du over 6x to the fifth power. And now we can take this integral into u world. This is going to be integral x to the fifth power still on the top, over, this is now u, and then we have a square. And the dx is that, so let me put down du over 6x to the fifth power. And you see, this and that will cancel, and we can bring the 1 over 6 to the front, and we can integrate 1 over u squared is the same as u to the negative 2, and that's the u. What do we do? Power rule backwards. So let's add a 1 to here. Negative 2 plus 1 is negative 1, and then divided by this new exponent, which is the same as saying multiply 1 over that, 1 over negative 1. So we know 1 over 6 times, this is also negative 1, right? This right here, we have negative 1 over 6. And then u to the negative 1 power. Well, we can write this as negative 1 over 6 on the bottom, and then u to the first on the bottom as well. Altogether, I'm going to write this as negative 1 over 6 right here, and the u is that. 1 plus x to the 6th power, okay?
So this right here, I'm going to put it down here. And you see, this is a pretty hard u sub question in the integration by part question. And let's go ahead and put that down right here. Negative 1 over 6 times 1 plus x to the 6th power. And now this is how we construct the answer from the DI method. Remember, the product of each diagonal is part of the answer already. So I'm going to multiply this and that's the part has no integral. It's the answer already. So let me put it down right here. And don't forget to account for the signs. This is positive, this is negative though. So it's going to be negative x to the 3rd power times that. So let's put on the x to the 3rd power on the top over that. 6 times parentheses 1 plus x to the 6th power. Okay? And then the product of each row, especially this second row, this is still an integral. Okay? And now let's multiply that. Negative times negative becomes plus, and it is still an integral. Okay? And let me put this on the top. 3x squared over 6 parentheses 1 plus, and I see this is x to the 6th power. I'm going to look at that on purpose as x to the 3rd power and then square. Okay? X to the 3rd power square is still x to the 6th power. Okay? And why did I do that? Well, remember how to emphasize many times. The product of a row is still an integral. And this integral, in fact, we can do it. Now look at this. Because now, if I let u equals to x to the 3rd power, the derivative of u will be 3x squared. We can cancel with that precisely, huh?
U equals to x to the 3rd power, and we know du will be 3x squared dx, and then as usual dx will be du over 3x squared. And if you take this integral into u world, you know we have the integral, and then 3x squared on the top still over 6 right here. 1 plus, this is the u, so I'm going to put this in red. And then square, right? And then the dx is that, so which is the du over 3x squared. You see, this and that cancel exactly, and we have pretty much 1 over 6. And then integral, and then this is pretty much 1 over 1 plus u squared, and this is still du, right? And we know this part is inverse tangent of u, so we have altogether 1 over 6 inverse tangent u. By the end, what's u? X to the 3rd power. So this one here, we can just write it down as 1 over 6 inverse tangent, and inside is x to the 3rd power.
I'm not putting down plus c yet, because this is not the final answer. I'm going to write down right here, because I want to solve this, right? I don't want to do that. So, negative x to the 3rd power over 6 times 1 plus x to the 6th power. And then we're going to add the result of this, which is that. And then we're done. And by the way, I want to just be consistent in all my videos. That's why I keep isolating the dx, okay? Even though I know the derivative is right here already. I know that too. Anyways, this right here is the result of that. And we just put them together. Plus 1 over 6 inverse tangent of x to the 3rd power. We are done. Let's see. This integral is extremely fun.
That's it.